Greetings and welcome, friends. Mr. Waddy here. We are in section 4.3. We've been talking about transformations, and today we're talking about the rotating. So rotations. A rotation is a transformation. Bam. Look at all you. We just learned so much information right now. In which a figure is turned about a fixed point, all right, the center of rotation, rays drawn from the center of rotation to a point, and its image form the angle of rotation, all right, and there we go, I like it. A rotation about point P through an angle x degrees maps every point Q in the plane to Q prime so that one of the following properties is true. All right, you guys have seen this pattern, this routine before. So let's see, we've got, if Q is not the center of P, so here's point Q, Q is not the center of rotation, verified, then QP is equal to Q prime P. All right, so and if those measures are equal, then their segments are congruent, right? You guys got me? You got me? Got this? Right? All right, so, and the measure of QP prime is x degrees. Or if it happened to be on the point of rotation, which could happen, then it's just mapped to itself. Also, if I'm talking about rotations, notice that what they called a 40-degree rotation was traveling counterclockwise. Guys, did you see that? They done rotated it counterclockwise. So it turns out a rotation, here's right clockwise, here's counterclockwise. You got that based on the way the minute hand moves around the clock. There we go. This would be a negative angle, and this would be a positive angle. All right, so that's perhaps counterintuitive. I figured I would explicitly communicate that for you. All right, so here we go. Let's do an example. All right, so this example we're gonna do rip. Actually, I'm gonna run out of space, guys. Uh-oh, let's see, I know what I can do. Did I give you guys enough space for example 1? So let's see, draw a 120-degree rotation. Well, you can grab a protractor out of the box if you want to be exact. Yeah. Or actually, Anthony, if you want to just pass them out to our friends. Never mind. But what we would do is this distance, okay, is what we've got. You could draw that segment. Right, straight edge it. We would measure 120 degrees from there. Do I have a means? No, not quickly anyway. So I'm just gonna rough sketch this. So I would measure 120 degrees this way using a protractor. I'd mark that right there, right? And then I would measure out the same distance and draw that point so that these are congruent. And so this would be at A prime. All right, so that's about what 120 degrees looks like. So that's what we would get. So let's do another one.
Wait, I have a question.
Yes, question.
Never mind.
I don't mind. All right, so that's what we would do. That's how we would get to A prime. If I want to find B prime, let's see. Here's B. I would measure this, and I'd draw that edge. Oh, so you're saying like if I could figure out where B would be with respect to A? Theoretically, yeah, you could have one point of reference and then go from there. That's an interesting strategy. I like that. We're gonna commit to the to this thing though. Let's see, and then I'd measure 120 degrees from there.
Wait, what?
Why if you measured the line
The A prime is what I marked. Because it's 120 degrees from this. It's okay.
Oh, that's what you do. Okay. But can you make the line from P to B?
Yeah. Yep. And then I would measure 120 degrees from that line using a protractor. And I would mark that spot, and then I would draw a segment out. And you could measure it, so if this was like 3.3, you could then measure out 3.3. And you'd measure it out through that point from P and plot your B at it. All right.
Oh, you have to like actually measure.
Yeah, if it's going to work out. I mean, I'm drawing my sketch kind of not to scale up here, but you getting the idea. Let's see, and now let's draw, well, I was trying to draw these two segments congruent. Let's see, and here's C. So CP, draw CP.
I see, like right on.
All right, so C to P.
Oh, wait. So the line from P to B.
Yeah. Yep, those are going to be congruent and 120 degrees apart from each other. But of course. All right, and draw 120 degrees from my purple line, which notice, look at this angle right here. That's a tiny angle. So this, when I measure it 120 degrees, is going to be a tiny bit past the green line.
Definitely did.
And I would then measure out the same distance.
I have a straight line.
And that would be C prime.
Yeah, I did wrong.
What? I don't get it. How did you measure?
Wait.
How did I measure what?
Like, how did you know it's you? C prime. I did.
You would have measured it. So you would have measured like 2 centimeters and then go out 2 centimeters. Yeah.
I did right.
Here, and to measure angles. Here, Isaiah, you don't need to like walk around.
I mean, I'm asking.
Yeah. So you would use your protractor, right? And what you would have done when measuring one of those angles is you would have had the base of that kind of at the P there, and you would have rotated it to 0 out. So let's say I was doing the orange line, right? I would have set it up like this, and then gone out. Let's see, where's 120? Right there, it's marked there. So you'd have lined that up, and then the 120 was here. So yeah, I was off. I was off for mine. All right. So we'll do some more practice with these, but no, we don't. So let's keep going. Let's keep going. Don't worry, we'll have more time to practice that later.
I did it.
But mine's not to scale. You guys could construct one to scale. Let's see. All right, so in terms of rotation, you can rotate a figure more than 180 degrees. Did you know that? Yeah.
Yes.
So if A gets rotated more than 180 degrees, notice there's a 220 degree rotation. You would have to figure out, you could mark where the 180 was and then measure another 40, something like that, using angle addition postulate. Question, comment, Aiden?
So like, it's.
There can be. If I was telling you a negative angle, you would then rotate it clockwise. So it's possible to describe things that way. You'll see that more in pre-calculus.
So like, instead of having like, for like, range, would you have like 100?
You could, so yeah, a 220 degree angle would be the same as a negative, what, 140 degree? So yeah, so you could actually work backwards to get to the same value if you wanted. So there's multiple ways of landing at the same exact points using rotations, whether, through positive or negative angles. It's also possible to go beyond 360, but that's not that interesting. So if I did 580, I would have gone around once and then another 220. And it's like, what was the point of that? Like, I guess taking the scenic route, maybe. I don't know. But yeah, so you can, gentlemen, please. We can rotate beyond 360, but it's just not very interesting. Now, if I'm rotating at kind of 90 degree increments, it turns out if I have coordinates, because not all the time are you graphing or doing rotations on the coordinate plane. But if we are, there's actually a way to do a kind of coordinate conversion when you're dealing with very particular angles, all right, that are in 90 degree increments. So coordinate rules for rotations about the origin as well. So that's also for a very particular center of rotation. So notice this, when rotating 90 degrees about the origin, AB would land here, right? That's a 90 degree rotation. And notice I could have gotten that by swapping A and B and making B negative. I don't think that that's what you would have expected. Right? I don't think that's what we would have expected. If I'm doing a rotation of 180 degrees, that's something that I would have expected, I think. The opposite of both of those things. Here, guys, let's stop grinding the gears on our protractors, if you don't mind. Thank you. So let's see. 180 degrees would be negative A, negative B. And for 270 degrees, which is the same as a negative 90 degrees as we talked about, we would have had B and negative A. Okay, so when you are doing your homework tonight, be aware of this little chart, this table. It might be of assistance when attempting these problems. So, no, not even close. So for rotation, I've got time, don't worry. Don't worry. Rotating a figure about the coordinate plane. Graph the quadrilateral and rotate it. All right, and rotate it. So let's see, quadrilateral RSTU with those vertices and rotate it 270 degrees. So let's see, question. I could do this all graphically, but let's try using our new little property. Let's see if we can use this property up here. What is R prime going to be according to this property? Yeah, we're rotating 270 degrees about the origin. So flip them, and so that's 1, 3, and then which one becomes negative? Yeah, 1, negative 3. So let's see, what would S prime be?
1, negative 5.
1, negative 5, I like it. What would be T prime? For T?
Oh.
Sorry. Negative 3, negative 5. And U prime? Negative 1, negative 2. Yeah. So I could figure out much of the transformation without having had to create the graph. And they did ask us to graph this. I'll show you their graph real quick so you guys can see that. So notice here's where I plotted the points. Let's just do an analysis of R. So R was at 3, 1. And if I rotate 270 degrees, notice here's a 270 degree angle. These distances are congruent. There's R prime. R prime is at 1, negative 3, just as we predicted. And so guys, as you probably predicted, rotations are rigid motions. Yeah, if you wanted to do it after school. Yeah. That's the only day that I typically have meetings, or some Thursdays. Let's see, because a rotation is a rigid motion, all of its corresponding parts are congruent, labeled as such, which is probably what you guys predicted. So that's good stuff. Let's do a composition. And this will be the last example. So it turns out you can also compose multiple transformations simultaneously. Let me get a coordinate plane in here, and we'll do it. Yeah, this coordinate plane will fit just fine. And we'll do multiple transformations, and the order in which I do these would matter. So let's plot the points R. So that's 1, -3. There's R, original. There's S, 2, -6. 1, 2, 3, 1, 2, 3. There's 2, -6. So that's S. We're just going to deal with just this segment here. So it's not a shape, but you could imagine what that would look like. If I'm doing a reflection over the y-axis, we're used to doing that. I'll translate, reflect it to red for my image. So R to R prime, it's going to be perpendicular and equidistant. So there's R prime. S to S prime is perpendicular, equidistant. So there's after one transformation. So that's my reflection. And now let's do a rotation 90 degrees about the origin. So here from the origin, 90 degrees out, it's going to land right here for R double prime. And this one's a little bit tricky to draw. That ends up landing exactly on the line there. So S prime will be 3 more away over here for S double prime, sorry. And if I used the coordinates of those points, so let's look at just S prime. So that was -2 down 6, -2, -6. And if I'm doing an origin rotation 90 degrees, what did our property say? Flip them and make the B negative. So -2, -6 would have become for S double prime -2 over here, and now the opposite of -6 is +6. And notice that over 6 down 2 is in fact where that landed. So that same property still applies. All right, well, thanks for watching, Internet friends. Have a great day. Bye-bye.